guys. I don't want that. All right, let me start over. Okay, so we're going to go over load charts. Understanding crane load charts and capacities. What determines the rated capacity? A crane's rated lifting capacity shown on its load chart is determined by its physical limits. For most lifts, the limiting factor is the stability preventing the crane from tipping. For others, it may be structural or mechanical strength, like the boom hydraulics or winches. Older charts often use a bold line or shading to indicate where the limiting factor switched from stability to strength. Critical rule: the capacities listed are maximum safe limits and must never be exceeded. Number 2, the essential role of load charts. The load chart is the primary reference for safe operation. It provides the maximum allowable load for every possible configuration of the crane: boom length, angle, radius, jib, use, etc. Correct interpretation. Anyone planning or excluding a lift must know how to read the chart accurately. Accessibility: charts are permanently placed in the crane cab by the manufacturer and must never be removed. 3. Technology is an aid, not a substitute. Modern cranes feature load moment indicators, LMIs, and capacity limiters that warn of or prevent overloads. Do not rely on feel. Waiting for the crane to feel light or tip slightly is an extremely dangerous or outdated practice. Many cranes today will suffer structural failure before showing any sign of tipping. Aids must be verified. Electronic systems are not infallible. They must be tested daily for accuracy as a part of pre-operation inspection. Final authority: if there is any discrepancy or doubt about the LMI's reading, the official load chart is definitive authority. The lift must not proceed until the situation is resolved by consulting the manufacturer's guidelines. Okay, I'm going on to the next slide. Critical factors beyond the load chart. The load chart limitations. The load charts are calculated for ideal static conditions. They do not account for site conditions, an out-of-level setup, or soft ground. Environmental factors like wind, rain, or extreme temperatures. Dynamic forces created by starting, stopping, swinging a load, or by a moving crane itself. Conclusion: this is why operator training, experience, and safe work practices are essential to manage the risk that the load chart alone cannot address. The risk of backward overturn, non-stability limit. While most concerns focus on tipping forward under a heavy load, mobile cranes on tires are also at risk of overturning backwards, especially when the operating over the side. What is backward stability? The crane's resistance to tipping backward when unloaded. Vulnerable conditions. A crane is most vulnerable to tipping backward when configured with the shortest boom length, no load on the hook, maximum angle closest to vertical, minimum radius. Less than 15% of the crane's total weight on the wheels due to counterweight removal or improper setup. Dangerous actions. The following movements can cause a backward overturn by shifting the weight and momentum: raising or stopping the boom too suddenly, lowering a load very rapidly, dropping, releasing a load. Moving on to the next slide. Understanding capacity loss from site conditions and wind. Crane load charts provide ratings based on strictly controlled ideal conditions. In the real world, several factors can dangerously reduce a crane's actual safe capacity and lead to catastrophic failure. The critical need for a level setup. Requirements. Load charts assume that the crane is positioned within 1% in all directions for every configuration. Consequence of off-level setup. It causes side loading of the boom, where the force is applied to particular to its design plane of movement. This side loading puts immense unexpected stress on the boom structure and hydraulic components. The capacity loss is significant and uncalculated. Additional hazard. When swinging from the high side to the low side on unlevel ground, the load radius increases, further reducing the crane's available capacity. Moving on to the next slide. The dangers of side loading. Side loading can rapidly lead to structural failure of the boom. It is caused by positioning a load to one side of the boom center line, dragging a load sideways, initiating or stopping a swing too rapidly, wind pushing on the boom or suspended load sideways. 3. The significant impact of wind. Wind presents a major and often underestimated hazard, especially with long boom configurations. Increased radius. Wind from behind the crane acts on the boom and the load, effectively pushing the load further out and increasing the operating radius beyond the operator intended, leading to instant overload. Backward overturn. A crane with a long boom at a high angle can be blown over backwards by strong wind, even when unloaded. Safety rule. Lifting operations must be restricted or completely halted in windy conditions. The crane's load chart does not account for wind force. Core principle. The load chart is your baseline for ideal conditions. The operator judgment and strict adherence to safe practices are what manage the real-world variables the load chart cannot. Moving on, next slide. Dynamic load and operation limits. Static vs. dynamic loads. Understanding the difference between these two load states is fundamental to safe crane operation. Static load. The weight of the load when it is stationary and suspended. This is the weight used for all load chart references. Dynamic load. The extra force on the crane when the load is set into motion by hoisting, lowering, or swinging. Total load. The actual force on the crane is the sum of the static load plus dynamic load. This total force can easily exceed the chart's rated capacity, even if the static weight of the load is within limits. 2. The sudden hazards of sudden movements and rapid swing. Operational movements must be smooth and controlled to minimize dangerous dynamic forces. Impact loading. A sudden start or stop when hoisting can instantaneously increase the force on the crane by 30% to over 100%, leading to severe overload. Rapid swing hazard. Swinging the load boom too quickly causes two major problems. Side loading. Due to intra and cable lag, the load trails behind, pulling the boom sideways and creating dangerous, uncalculated structural stress. Increased radius. The load swings outward on its cable, increasing the operational load radius and instantly reducing the crane's safe lifting capacity for that configuration. Moving on to the next slide. Duty cycle and rated capacity. A crane's published load chart is typically for standard intermediate lifts. Certain types of continuous high-speed work require a different rating. What is a duty cycle operation? Work involving rapid, repetitive lifts with frequent swings, such as concrete placing, steel erection, or magnet operations. I'll even throw in trusses on that. The need for deteriorating. The constant dynamic stresses from impact loading, swinging out, side loading in these operations cause extra wear and strain. Therefore, cranes used in this way often operate under a separate lower capacity load chart or a permanent derating of 20%. Key point, a crane configured for a heavy single lift may not be rated for the same weight in a fast continuous production style. Safety summary, managing dynamic forces, operates smoothly. Always use a slow controlled acceleration and deceleration when hoisting, lowering, and moving to minimize dynamic impact. Anticipate swing plan, swing to avoid sudden starts and stops. Allow the load to settle and follow directly under the boom tip. Know the job. Confirm the correct load chart is being used. For high production, repetitive work, verify is a special duty cycle rating applies. Never assume the standard chart is valid for all types of lifting. And here's just a breakdown of the load chart that we have. And as you can see, we have the component limitation and then the stability, which is that bold line right there. And this is an older chart. We have the bold line here and you have the lines here. So this is your structural and stability. Do you have any questions on that?
No, sir.
Pretty self-explanatory. And you got all, so with the trusses and stuff, you're going to have a lower rating on these cranes that we use basically. They're not going to be the same as a crane that is just doing a couple lifts a day, going real slow. And these cranes are beat up, so you got to make that 20% capacity deduction.
Gotcha.
Okay. And that's it. So that just breaks down some fundamentals when you're using the load chart. You got to make those considerations that that chart that you got to always be a little less than what that chart's giving you. And okay, so that's it for today.
All right.
I'll send you quiz
5.